Welcome to Perspectives with Wenchi Yu, where we analyze the policies and political strategies of Trump 2.0 and their implications for Asia, China, Taiwan, and beyond. After President Trump's White House announcement of TSMC's $100 billion investment in the United States on March 3rd, reactions in Taiwan have been mixed. TSMC Chair C.C. Wei and President Lai Ching-te held a press conference upon Wei's return to Taiwan to reassure the public that TSMC's most valuable R&D capabilities will remain in Taiwan and that the company remains committed to building fabs in southern Taiwan. Since Taiwan's initial announcement of its Arizona plans during the first Trump administration, many in Taiwan have expressed concerns about losing the island's competitive edge in the U.S., from fears of the semiconductor industry being hollowed out to worries about losing its silicon shield. Many Taiwanese believe TSMC's move is a result of U.S. pressure. It took Taiwan decades to establish itself as a global leader in high-tech hardware manufacturing. The journey began as a government industrial policy aimed at securing a future for the impoverished island after World War II, relying on highly educated and hardworking engineers who left Taiwan in the 1960s and 70s to pursue advanced STEM education. Thanks to U.S. immigration policies that attracted STEM talent, waves of top engineering graduates immigrated to the U.S. and contributed to the growth of the semiconductor industry in Silicon Valley. When those engineers returned to Taiwan after gaining experience in leading technology companies, they helped establish Taiwan's own Silicon Valley, Hsinchu Science Park. Today's guest is Konrad Young, a prominent thought leader in the semiconductor field in Taiwan. Trained as an engineer at both National Taiwan University and UC Berkeley, Konrad has worked for HP, Charter Semiconductor, and TSMC. His life journey mirrors Taiwan's semiconductor history. Now a media favorite in Taiwan, he shares his experiences and insights through teaching and speaking engagements. Konrad was kind enough to sit down with me twice, and you'll hear both of those conversations now. There's a lot international coverage about semiconductors, but usually we don't hear from Taiwan like you, who's actually a real expert who spent time in TSMC and now in academia to share with us the perspective.
1959, the year before I was born, there was a fight between Taiwan and China. There's the war called August 23, 823 炮战. That was the time Taiwan was in kind of a troubling era. And so when I was born, the Taiwan was a very poor country. There's essentially no any meaningful industry at that time. I still remember during the time, most of the family, they would bring some small project to their house, and then the kids and then parents are doing outside their regular work. So it's considered the entire country is doing family factory, and those are very low level kind of job. It's a more or less labor production period. Mm-hmm. I think the most intriguing event for me is 1969 when I was 10 years old. When Apollo 11 landed on the moon. Neil Armstrong say a small step for him and a big
a giant step for humankind.
Giant leap for mankind. Yeah. That phrase kind of inspired me to go to the so-called scientific technology area. Okay, it's inspiration, but exactly what should I do? So I start to be interested in science and technology area from that time, and then got a good score, passing all the tests to get a first choice when I went to college as National Taiwan University Electrical Engineering Department. Yeah, it's still probably the best today. Right. in the technology area, in the engineering STEM area. I devote myself into semiconductor area at the junior year of my college.
Why were you interested in semiconductors?
Well, I guess because I'm very good in physics, chemistry, and math. And during the electrical engineering department time, the person who are good at this subject is entitled to take a so-called solid state semiconductor area because it require very fundamental knowledge of physics, chemistry, and math. Okay, for that. So because I'm good at that part and I'm less interested in circuit design during that time. Okay, so I didn't go into the other application like telecommunication. During the time, Taiwan doesn't have any semiconductor industry. So
that was in the 70s, right? In the
that was
1970s.
I graduated in 1981. So
So
actually,
late 70s,
UMC started, but I didn't know that. I actually take an intern during my sophomore year in Shenbao Electronics. And that intern job was such a terrible experience. And I swear to God, I'm not going to work in Taiwan because essentially to me, there's no good job in Taiwan after I graduate from National Taiwan University. So
but it
only
was
way.
also during a time that I think your generation and the generation before you, because the US changed its immigration policy, so it started to attract a lot of students in STEM to move to the US, right? So there's a whole generation of Taiwanese engineers working in Silicon Valley, working in Ohio or, Texas, in different parts of America, contributing to the US technology advancement.
Exactly. There's a slogan during the time when I was in National Taiwan University. We call "Come, come, come to Taiwan University. Go, go, go to US." Okay, that was
So
extremely
everyone literally had the dream of moving to the US, and
exactly. It's basically the social movement. We are just individual under that current. Extreme current to push us to go to US because there are not much going on in Taiwan. So going to US for so-called American dream is the dream for almost everyone in college. Okay,
right.
We are so poor. We cannot afford to go to US. So when we go to US, we have to get some kind of tuition support, scholarship. Right. That's the time U.S. Has some money for some of us to. I went to Berkeley. School. Yeah. One thing definitely different from National Taiwan University is they are a lot more advanced than Taiwan education. There are facility which we never saw when we were in Taiwan. In Taiwan, when we study in college, we can only learn from textbook and very little from professor because all the professor experience is way before semiconductor era. So how can they teach semiconductor when they don't have any experience?
Real experience, yeah.
Yeah, and they can only read a textbook and then read to us, and we can also read it from the textbook. And just talk about the Taiwanese education for those people who stay in Taiwan, couldn't get good semiconductor education in college. How do they develop their experience? After I graduate, before I graduate in 1974, there was a institute called E3, Industrial Research Institute in Hsinchu. E3 and 19工研院 yeah, okay. Exactly, 工研院. And they started in 1973. In 74, there's the institute come out from E3 called ERSO, Electronics Research Organization. So that, and they start to build some kind of fab. Okay, in 74. And those are the incubation center for semiconductor talent in Taiwan. I'm talking about those people who didn't have a chance to go to US to study. So Taiwan's talent was developed in parallel. One, of course, like me, we went to US. There are roughly about 30 years talent went to US to study and work in the major league of US semiconductor industry. Another parallel path is those people who stay in E3. And why it's so important for E3 is E3 play a role of incubation of Taiwan semiconductor company.
And it was set up by the government, right?
It was a strategical goal set up by government. Yes. Okay. So 1974, I mentioned this project started. And then after roughly about 6-7 years, they spin off one particular company called UMC, United Microelectronic Company. That's the first info semiconductor company in Taiwan in 1980. 87 years after UMC spin off, E3 spin off another company called TSMC in 1987.
Why did the Taiwanese government see semiconductor as a strategic investment?
I don't think at that time Taiwan government has many choice. If you think about it, in 1970 something, the way Taiwan government was doing, every year they invite overseas expert, the so-called Chinese background expert. The Taiwanese government look for the advice for those people who original went to U.S. From mainland China, even before 1949.
People like Morris Chang, right?
Like Morris is one example, but among Morris, there are so many people. And there's a particular person which has a huge contribution most people in outside of Taiwan didn't know. It's more important than Morris, I would say. The person's name is called Pan Wenyuan. In Taiwan, there are still a lot of like Pan Wenyuan Jijinhui, the foundation for Pan Wenyuan. And he is also from mainland China to U.S. And he worked in U.S. company called RCA for a while. He was in R&D as one of the advisors to Taiwan. Morris wasn't involved in 70. Yeah, back then. Morris come to Taiwan in 19 around. That's way after the E3 started. E3 started in 73. Dr. Pan was in RCA. The only advice he could give is semiconductor. He suggests Taiwan should focus on semiconductor. That was the time 70 was rising sunrise phase of U.S. Semiconductor industry. So you can think about the 70 was the first phase of U.S. Semiconductor rising. Of course, before Intel, there was a Fairchild, there was a William Shockley Semiconductor, but that was early phase. Okay.
So Intel already started, right?
Intel already started. Intel 68.
Texas Instruments as well.
Texas is much earlier, 50. So Dr. Pan make that suggestion. And that's why the E3 start to have the so-called RCA project, send 20 people to RCA for training. Today's leader, including Robert Chow, Cao Xinchen,
UMC founder.
Yeah, yes. UMC founder. So many founders, other than Morris, are from E3, are from that around 20 people. So young engineer went to RCA. They are essentially the founding member of Taiwan semiconductor industry.
For people like you, students who went to the U.S. to study, there also seemed to be a whole group of students who are involved in semiconductor development. And then later, a lot of you spent time in American companies and then came back in the East to help build up the Hsinchu Science Park.
Yeah. So we just talk about what happened in Taiwan. Mm-hmm. Now let's move to the other path. What happened in U.S. Mm-hmm. Okay, U.S. Semiconductor industry definitely is a founding member for entire worldwide semiconductor, starting from William Shockley, and then Shockley Semiconductor, Fairchild, Intel, AMD, and go on. Okay, have roughly about 30 years. Taiwanese students, STEM educated students, went to U.S. to study. I mean, electrical engineer, there are people go to physics, people go to chemistry, material science, civil engineering, all the engineering area. When we went to U.S. Around 70 to 80, that was a golden era for semiconductor industry. I still remember when I was at Berkeley, in electrical engineering and computer science, roughly about more than 60% of the students are in semiconductor. This is very different.
Now it's kind of different, right?
Yeah, this is totally opposite.
Yes.
Totally opposite. And that's why today's Berkeley electrical engineering and computer science, they are 80% of computer science, less than 5% in semiconductor. So semiconductor industry to US from a rising star to close to a sunset industry.
Explain that part, because as you know, President Trump has been complaining about Taiwan stealing semiconductor jobs.
Yeah.
And President Biden would say the US outsourcing semiconductor industry jobs to other parts of the world. And so you experienced that period of time.
Exactly.
Can you share what happened?
Yeah, I definitely experienced that. After I graduated from Berkeley, I went to MIT Lincoln Laboratory doing more kind of satellite electronics semiconductor. And then after 2.5 years, I went back to Silicon Valley, work at HP. I was involved in 0.8 micron to 0.5 to 0.35, 3-generation technology development at HP. Okay, I definitely experienced the changing atmosphere for semiconductor industry in US. I still remember when I first joined HP in late 80, a lot of companies from Taiwan come to Silicon Valley, try to recruit talent. I was recruited by UMC, TSMC, Micronics, and so many Taiwanese semiconductor companies.
But these Taiwanese companies were all supported by the government in the beginning.
Well, definitely in some way, especially like UMC and TSMC, the first fab was almost free from government. Think about that. There was the E-Trace fab that spin off. So government already spent money.
Incubated by the
government. So you can say that. And definitely the other company also in some way, but the smaller scale way are supported by government. But they are very tiny. So during the time when I was HP, I was somewhat interested because it's my homeland. But because the company was doing so poor, UMC, TSMC, Micronics, and the salary they gave us was terribly low. It's probably less than 10% of my US pay.
Mm-hmm.
So as an individual, definitely.
Of course, it's very hard to attract people back to Taiwan. Right. So how did they come up with different kind of package in the end to entice more Taiwanese engineers back?
I give you some example. There are few senior people than me, 5 years, 6 years. They went to Taiwan. Definitely, they see the hope. They see the future. So they went to Taiwan to work at many companies. Even at the TSMC. After a few years, they come back to US because after so many years sacrifice, they got not much. The early package is they give you salary, but they give you free stock. But the stock, if they are not IPO, is almost equal to wallpaper. So if you just look at that number, still not attractive. They couldn't wait until the company go IPO, and they lose their life so much. They gave up and went back to US. So when they come back to US and we chat with those people, you can see how much incentive for us to go back to Taiwan. There are already people fail the trial. And also the environment was not very good. Hsinchu was a small town. The living environment is terrible. Okay. In fact, I reject TSMC twice during that period of time. Okay. Why I'm still interested in Taiwan or in general Asia? Because when I was in HP, I sensed the wind moving to the far east. I actually sensed a wind.
80s, right? That
was a 90 already, early 90.
It's already in the
that
90s.
Was early 90. Yeah. So during the time, I sensed that the U.S. Manufacturing culture, especially at HP, wasn't really there. The U.S. is very strong in research and development, but they are not the same as so-called the Asian manufacturing, the so-called tedious, hard-working kind of job. Master PhD student has zero interest in so-called manufacturing. Because those jobs are supposed to be done by bachelor or even high school degree people. We consider as a blue-collar job. It's not a knowledge worker job because we develop technology, we transfer to the manufacturing. They just need to follow, push button, execute it accordingly. So it's not fit to the so-called U.S. Semiconductor talents. Also, starting 1980, even before that, we actually joke about semiconductor industry as IC industry, integrated circuit industry. You know that, yeah?
Yes.
We actually joke the IC industry means Indian Chinese industry.
It still kind of is in Silicon
It,
Valley.
it is still kind of true, yeah. So you went to the company and you see all the semiconductor company, Intel, AMD, you actually see more than 50% employee are either Indian or Chinese. And then Chinese, of course, a lot more
Taiwanese.
The Taiwanese, yes.
Yes.
So IC industry was pretty much an immigrant industry. Another example is Andy Grove.
Yes.
Andy Grove was from Hungary.
He's the founder of Intel, right?
He's an early player. The founder is actually Bob Noyce and the Golden Moore, but he joined the team in the first phase. But he was the key person to execute it. He made Intel to great. Right. And the problem today, Intel, how can make Intel great again, like America has a similar reason.
Mentality.
Okay? Yeah. So the semiconductor industry, especially hardware industry, is really culturally fit for immigrant, not for the traditional U.S. Education system. For U.S. people, they don't need to go to STEM education to be competitive. But for Asian people, especially for foreign students, other than STEM, they have no competitive advantage.
Right.
So that's why most of people went to U.S. For STEM, and that's the relatively weak part for U.S. That's why the semiconductor was such an immigrant industry. Software is a bit different. Google, Facebook. If you divide the high tech into two parts, one is hardware part, the other is called software part. Semiconductor is the hardware part.
Let's then focus on hardware because that's where Taiwan really dominates. These days. So you were saying a lot of immigrants went to the US and became the brain of the semiconductor industry. But how come it started to move back to Asia? And how did Taiwan become the best now in the world in terms of hardware manufacturing?
I would say globalization is a key. Asians start to play some role, especially in the so-called high volume production. But Taiwan, at that time, the technology was so far behind. From us working in U.S. As a leading edge company, we don't consider them to be any threat at all. That's why the globalization really started. They asked the Asian to do the lower level or older generation of technology, which U.S. already have it. They are moving ahead. The old one, if they continue doing that, they are wasting a lot of money doing production. Why don't we ask the Asian people to do the lower cost production? And the globalization movement is more or less like this. I want to go, and that time I see the trend, but I didn't go to Taiwan. I went to Singapore. CC Wei hired me as an R&D senior manager.
Is it for TSMC as well in Singapore?
For Charter, and later merged by the Global Foundry. On my first day after orientation, I went to see CC, and they told me my job has been changed. Tomorrow I'm going to Fab. I was extremely unhappy during that time because, again, I mentioned I had a PhD. Doing manufacturing job is a blue-collar worker.
Right.
So I don't like it. But I had to say that was the best job in my career. To go to Fab, because there's a reason for that. Because the Asian R&D was doing in the manufacturing fab, not the R&D fab in US. How did you do R&D in the manufacturing fab? You had to understand the culture. I had a two job in manufacturing, which helped me merge the R&D and the manufacturing mingle together seamlessly.
Can you explain that for someone who doesn't come from that background? What does that mean you can do R&D in a fab?
When we talk about R&D, we normally talk about in the laboratory environment.
Right?
In the university. Okay, yeah. We call in the laboratory environment, or in US company in called R&D fab. That R&D fab was designed for R&D. Means it gives you some flexibility because what R&D was doing is its own world. We had to try all kind of new things. Otherwise, we don't call R&D. Right? But high volume production is completely opposite culture. I don't want you to change. I want you to control what we already existing, make it more and more perfect, and then tighter and tighter control. So R&D and the pure manufacturing are completely different, opposite culture, and mingle two culture together is a challenge. Okay, if you don't have both experience, you have no idea what the heck is going on, because manufacturing will restrict you to do all kind of R&D. Okay, because you are causing trouble to my volume production.
Because if you change something, the impact is tremendous, right?
It could. If you try something very dramatically, it might contaminate my entire line. My whole production is down to the drain.
Yeah.
If it's not because of God push me out of a comfort zone, I would never apply for any manufacturing job. Heaven definitely blessed Taiwan as a semiconductor island or semiconductor country. There are too many things somehow heaven created. First, back to the 1970s, heaven make Taiwan as such a terrible place, force us to go to US to study. And we work in a major league in US and develop as the best talent group with 30 years. If that definitely is not done by any government.
You see, Japan also was the leader in the 80s, I believe.
Yes.
And then several other Southeast Asian countries, including Singapore, also tried to become the leader of semiconductor. How did it all end up being in Taiwan?
So again, in quick summary, Taiwan was blessed in many ways. Okay, the timing, the location, the people. We can talk about Japan. We can talk about Korea. We can talk about Singapore. Okay, Japan dominated the world. Is the peak year is 1988. They have 50.3% of market share globally. US during the time only 35%. And because of they are dominated the semiconductor industry, they pretty much was killed by US government. With the exchange rate change, they double. I remember when I first went to Japan in 1985, it was like $1 to close to 260, and then the next year it becomes $1 to 130.
Yeah.
So double the currency value, and make the cost almost double.
Was it intentional as a U.S. policy, or
yes? There was a negotiation. There's we call I forgot the English name called we call 广场协议. There's a treaty. Basically, Japan was forced to appreciate their currency because they are dominated the world. Okay, and the second one to kill Japan is they help Korea to grow up. That's when Samsung and other semiconductor company come out, and then the Korean semiconductor industry is designed to kill Japan.
They wanted to compete with each other.
Yeah, they basically take the Japanese strengths and focus on those areas. One is called DRAM, the other is appliance semiconductor in the supply. That's why the Samsung TV becomes so strong, and Samsung's memory took over Japan. Basically, Korean took over Japan, not US took over Japan. Taiwan is very lucky. Nobody wants to kill Taiwan. And when TSMC started in 1987, they choose a business model called foundry. In fact, foundry model was started much earlier in US. When I was at HP, we are also doing foundry, but we are doing so-called part-time foundry, not a full-time foundry, not a dedicated foundry. So foundry model is not new at all. In the traditional IDM company, we took some extra capacity to help some company, but primary is still our own product. HP has its own product, but we have some extra capacity. We help a small company. HP was doing something for a company called Actel. I'm not quite sure still
And
exists
it's
today.
usually because they're clients, right?
Usually because they have an extra capacity
Mm-hmm.
to help a specific client, which is complementary to their product, definitely not competitive to their product. Okay, and TSMCs are a pure foundry, and during the time, nobody want to do a pure foundry because it's low margin, the product is the king. That's the so-called IDM mentality. Now let's go back to the culture. Why Taiwan is so fit to the foundry? One simple reason is Taiwan has a very, very small domestic market, and only thing Taiwan eyes is the global market. IDM has its inherent culture. They have their own product sell to domestically. Japan, all the semiconductor industry trying to sell domestically to the appliance to go overseas. So semiconductor industry, for IDM's point of view, has this domestic centric. DRAM is a little bit different. DRAM is a global market, but it's so standard. But logic foundry, your customer varies a lot. If you want to do a foundry, that means you have to spend a lot of effort to do a global customer with various applications, and that's very troublesome. It's more or less a cleaning mate's job to help clean their other people's house. The house is not yours. The end product is not yours. You just help them to serve. When TSMC started the foundry, it first started as a global market. But whether the global market want to take you is a different story because they all have their product. So in general, for TSMC, the first 10 years, they are doing for IDM's product. The majority of them is IDM's product. Like Intel has a they have already technology 10 years ago, and they don't want to do it by themselves because cost is too low, but they still have to fulfill the market. So they ask TSMC to do something. Intel transfer that old technology to TSMC, and TSMC only doing manufacturing. So TSMC first 10 years.
TSMC was willing to do things that nobody else wanted to do.
Exactly. So TSMC doesn't have any competitor because nobody wants to do it. So foundry start with dedicated foundry start with no competition. UMC was an IDM company. They have their own product. But Taiwan is not an ideal country for IDM. I mentioned about E3 has a original mention about two company, 1980 UMC, 1987 TSMC, and 1994, 7 years after TSMC, has another company called Vanguard. It's a third fab spin-off from E3 doing DRAM. UMC and the Vanguard start with IDM. After a few years, they gave up. They all become a foundry.
So all of them became foundries.
All of them become foundry. Yeah. It's very, very hard to do IDM in Taiwan. In Taiwan. Culturally, also, I think the market, the domestic market, global market mindset is very, very different. In many countries, US, Europe, Japan, and since Korea followed Japan, they all have this IDM mindset from very beginning to even today.
Because they have enough domestic market to do IDM. Yeah.
You can say that. Say that. Basically, is using domestic market to drive. Of course, that so-called domestic market, their customer may go globally, but for semiconductor chips, they are close to the global market, except the standard product called DRAM. But logic has many variations from PC to internet to mobile to today's AI. They had to change all the time. There's no one standard could fit all, with all movement. So doing the logic foundry require a lot of versatility, certain flexible culture, which is very ideal for Taiwanese. because
And they had to do whatever the customers asked them to do, basically.
I mentioned about family factory back to my young age. Anyone give me a milk, I would call them mother. In Chinese, we call 有奶就是娘. So we are so flexible. Anybody in the world could be our customer. That culture exists in Taiwan. From so-called 加工出口区. Now let's look at Singapore, because you asked about Singapore. Singapore is a little bit different. Singapore is actually very business-centric country. The semiconductor to Singaporean is also considered blue collar. Their best talent is not going to semiconductor. They go to business, go to politics, go to medical. So Singapore doesn't incubate any STEM, especially hardware educated talent. The Singapore talent mostly coming from Malaysia Chinese and also mainland Chinese.
Right.
Okay. So they have a very different way of running it, but because this is too small, they couldn't compete. They are good in manufacturing, but very, very weak in engineering. They don't have a talent. And Taiwan, as I mentioned, during my time, the percentage of a high school graduate has roughly about 50% of people in STEM, 50. If you look at the
you have those schools that are vocational schools, right? That they train. Yeah.
Actually, more than vocational school. The 50% is partially related to that. But even the regular school, Taiwan University and so on, the STEM education still very dominant. The reason why it's very dominant is very simple. During the time for us to go to US to be competitive, only STEM, social science, especially literature and then culture. How can we compete with the US?
And language,
language, culture. Without that, and then STEM education is the way to go to US to be competitive enough.
So Taiwan always has a very strong STEM education tradition.
Yeah, back to my time. So it has a foundation of a STEM education. And then I mentioned the talent was not just because that foundation is still not good enough. For higher education, we have two paths. One went to US to train. The other is go to E3 to train. So both sides are very successful. And in 1990, milestone is in 1994, all these company go IPO.
At the same time?
Almost the same years, around 94.
Why is that?
Okay. I guess the environment get to the point and they start to make money. They don't make money. And then Taiwan stock market and the Robert Chow has this so-called the stock option, stock bonus plan. Very unique stock bonus plan, which I didn't see in US. Free stock give to us can equal to real money. When we receive the offer, we can easily calculate how much it worth. And we find out that money is almost equal to US pay. And that's why I went to Taiwan in 1995. We don't have to second guess the future. It's already real. It's early phase, so we still have growing chance. And that's why after this company go to IPO, there was a huge returning movement from US.
Yeah,
that was a 94, 95 period.
Yeah, I actually do remember that because I grew up in Taiwan as well. I was still young at that time, but I do remember there was a huge effort to recruit not only Taiwanese, but just anyone with sort of ethnic Chinese background to come back to Hsinchu Science Park, right?
Yeah, exactly. If you look at the Taiwanese semiconductor industry from revenue point of view, from 74, it took 20 years for Taiwan semiconductor go from single-digit billion-dollar industry to two-digit industry. Roughly happened in 1994. Okay. And since that, it's going higher. Okay, the trend is almost exponential growth.
Actually, because you had all these talent coming back, The
Yes.
companies become public, probably run better and more professional as well. And
Yes.
then it's a globalized world. So the labor division is probably clear. You came back to Taiwan in 1995. And so what
Yes.
did you experience?
TSMC need more R&D, need R&D people urgently. They want someone to have R&D experience to bring TSMC up. Honestly speaking, the first week when I joined TSMC, I was shocked. I didn't know how bad TSMC R&D was. TSMC was a very good manufacturing company, but they do not have the infrastructure and do technology development from scratch. The first week, the first month, everything we do kind of feel I had to build a skyscraper on top of it with all the soil. So we were doing technology development. In the meantime, I had to help the infrastructure. So it was the toughest job in my life. At that time, 0.1 later, I think we probably have at most 200 people versus today is 10,000. So 50 times smaller size. And we had to develop also a new generation technology with much poor infrastructure. And our yield is zero for a long time because
Wow.
of design error. There are so many things, and I have to work going in the early morning and then come back almost at midnight. And on the daily basis, fix all kind of problems. There are so many fires going on.
Mhm.
That's what I first experienced the work ethic of Taiwan. It seems like everyone devote their life. I mean, real life. When
Yeah.
you can be.
Do you think that culture is more innate Taiwanese, or is it because that was sort of the founding stage of TSMC? So people were more committed because it still felt like a startup.
It was not really a startup, except in 11 years. So you cannot call 11 years company as a startup. But for R&D, it definitely has a startup spirit. Because of we never done a meaningful R&D before, but we did it before. We just need to change the environment and bring the people together. So that's I can my mentality, and I will. You have such a strong will. I mean, we almost willing to sacrifice our life to make it happen, and that mindset. That strong desire, strong will is very important, especially and that's the early times of TSMC.
Is it still the same, or is it less so?
It's a little bit different. I think it's a combination of everything. It mentions it comes from so-called culture, Confucius culture, hierarchical, the top-down, and then in Confucius culture, they sacrifice the small self for the bigger
more
goal.
collective kind of culture.
More collective culture, and so many things. And also that was in 1990. That was a time Taiwan still relatively poor, not rich. For them, the only thing they have to do is fight for the future. So they consider being poor kind of build their strength, their will in their early life. All this combination happening from baby boomer to maybe X generation. And today, definitely different. When you have a lot more Z generation or Alpha generation, and in a much wealthy or comfortable environment.
Do they work as hard or no?
They will in some way maybe forced to do a bit, but in their mind, they definitely don't have a sacrifice mentality anymore.
They probably don't have the drive like you guys.
They don't have a drive, the will to make it happen. But we have a lot more people, 50 times more. So it's a little bit different. And also, because I spent 20 plus years to develop the infrastructure, today's TSMC infrastructure is much better than any company I've been through. even as early as recent as Intel for 2 years, 2021 to 23. I consider
Can we talk
TSMC infrastructure is better. It's much better than
even in the recent debate about whether TSMC is being hollowed out? I've seen you talk about it a few times that R&D will still remain in Taiwan. What does that mean? Why do you think R&D will always be in Taiwan?
Because it's the most productive environment today. So we improve the infrastructure for the past 24 to 30 years. Now, to the point, I think becomes well ahead of the original very, very good infrastructure company, including Intel. So we learn from US about how the environment need to be done, make it surpass the US semiconductor company, at least in the R&D area.
Outside of R&D, would you say that applies to all areas, which means Taiwan is catching up and surpassing?
TSMC manufacturing has been ahead of US long time ago. But R&D surpassing especially the infrastructure surpassing is probably very surprising to anybody in the world. It's actually surprising to me because the Taiwanese has a culture called 勤能补拙, working hard to fill the gap of stupidity. Okay, we could be stupid, but we just working hard using long hours to overcome that. That's exactly what happened. The working hard mentality, commercial available, and that's why your question is TSMC R&D doing it in Taiwan is the best place in the world. That including everything, including the infrastructure, is better than anybody else.
Can you explain what you mean infrastructure? What are some of the examples?
If we use the current hot topics called AI, and let me give you an example. When I was at HP, I already built a so-called digital twin for myself, a replicate of me in HP with a computer software, so that when I sleep, my digital twin still working because they don't need to rest. They just need to plug it to the outlet, electrical outlet. They can work. And that time we call as expert system. Expert system is before the so-called big data AI. Large language model is just one big data AI application. And the AI tool to make everyone do everything when they are sleeping is an important part of the infrastructure.
Sure.
It's actually
efficiency and productivity and a lot of.
It is. It's a productivity tool.
Yeah.
And that productivity tool, typically, I look at it 10x to 100x. It's not 10%, 20%.
Yeah.
I only do 10x to 100x job, and which I try to make a system to reduce all the tedious activity of R&D and make a computer do it for them. And then the people only do work on that with their intelligence, with their decision, their wisdom, whatever the real human being is good at that. Try to let our engineer doing that part. If the machine whenever machine is good at it, I will ask the AI system, and you have to work seamlessly between human and then the system. So the system is actually a culture. So is seamlessly making the R&D people work on the so-called conflicting manufacturing environment to make things easier, a lot more productive.
So right now, Taiwan or TSMC has the best R&D in the world, right? No doubt.
No doubt. So that's why you do things in the best place in the world. If the US is better, TSMC could do that in US. Can it be replicated? At least partially, because the U.S. has an AI mindset much better than Taiwan. But their expertise in technology development and management, they lose that manufacturing domain knowledge, domain experience now. And they just need to bring that domain back to do it. I personally believe it can be, at least partially can be replicated. That's what when I was at Intel as an advisor, I suggested them to go for that. But yes, too many politics
Other
going on.
reasons.
So
Yeah.
that's the
Yeah.
reason.
Well, can we also talk about a period of time when there was a lot of Taiwan-China collaboration? UMC, TSMC, they all started building fabs in mainland China. And as you mentioned, SMIC was also founded initially by, I think, mostly Taiwanese. How did that work at that time?
I think China's semiconductor really started in 2000. I think SMIC is the key milestone for China semiconductor. And honestly speaking, that team definitely cannot compare to the so-called first-tier team in Taiwan. I'm just talking about the year of 2000. They have a good team. Richard Chen, EYQ, he was there also. But China, the infrastructure at that time is a lot worse than Taiwan already. They were pretty far behind. And so they have a Taiwanese experience. They try to replicate that. Maybe SMIC is try to shortcut something. There are some legal fight between TSMC and the SMIC. I was the technical lead for TSMC because they go the 0.18, 0.13 micron technology to SMIC. Those technology, I was in charge of those technology. So naturally, in Oakland Court, the legal court, I was the primary witness for that testimony for those kind of court fights. They have some the experience, but they definitely don't have any infrastructure, and they couldn't buy it in the world. So they struggle, but they are still the biggest company in China. Before SMIC, the China semiconductor is very tiny. Around 2000, that was the time China grew very rapidly, start to grow, especially on the internet, especially on the so-called consumer-related industry. Think about that. If you are a person, you are any talent, and you are a company, do you want to work on semiconductor, or do you want to work on those internet software?
Yeah.
Semiconductor to China is really a second-tier, third-tier industry compared to the primary consumer-related industry. So they start with it's worse in situation. Not like Taiwan. Taiwan in 1990 already is a dominated primary industry, and the people all go there. So these two just cannot compare.
Right.
Yeah.
The timing, they started late, and there was another thing that was more attractive. But then why did they, it seems like in 2010-ish, around that time, there was a serious government effort to focus on semiconductor manufacturing.
Definitely. One reason China want to build their semiconductor from government point of view, China also become, in addition to internet, it becomes a so-called world factory. Then they build cell phone, they build PC, they build almost all the electronic product from everybody for global customer.
In a way, would you say they almost replaced Taiwan in that kind of manufacturing?
Pretty much, yeah. That was 2000 in the so-called ICT, the more end product system assembly of the final product. Taiwanese company also moved to China because of labor costs. China also was leading manufacturer for end product, and partially they also have a population customer. So those products can sell to their own people. So China after 2000 becomes the downstream market point of view, the number one in the world. And even in semiconductor, because the so-called semiconductor market means you buy semiconductor chips, and they are the dominant buyer for semiconductor. But if all the semiconductor chips are coming from foreign country, for any government point of view, is definitely not a good idea. And they have a market to grow that industry anyway, and that's why government decide to pump some money into it. And definitely market-driven is most effective way to help the industry. No doubt about it. Just government itself is not, okay? So that's how SMIC
Do you
start
think
to
they're
grow.
catching up as well?
They're definitely catching up, but again, they're still weak. They can only make certain chips, which is not the so-called leading edge technology. You talk about SMIC, I consider their previous best CEO is T.Y. I recommend him. SMIC is not going to compete with TSMC. They are too far behind. So they should focus on the so-called mature technology. At that time, up to 40 nanometer, very recently. When they try to get into a 28 nanometer, they find a lot of problems. They don't have enough right talent to overcome the difficulty of 28. Another important milestone is Meng Liang. Meng, when he went to SMIC, in a short time, almost 3 years, he brought up SMIC technology 28, 14, 12 to 7 nanometer.
Yeah, 7 kind of
he was an amazing guy. He moved SMIC into more advanced technology. And
is he also from TSMC, a veteran of TSMC?
Yeah, he was a veteran of TSMC. He left TSMC at the time of the 32, 28 nanometer. So Meng bring the SMIC to the more advanced technology. Unfortunately, because of Huawei, because of SMIC under U.S. sanction, they were almost at the 7 nanometer. They will continue going, but without the EUV, it's a very, very difficult job. Nobody else can do it.
So you do think U.S. export controls have had an impact on China's?
Strong, very, very, very strong impact. That basically kill in China they call it basically
choking
their neck.
Yeah.
They couldn't sleep. And they were working on some way of 5 nanometer, 3 nanometer, but it was definitely not more competitive enough. Without the UV, they are handcuffed to do things. But you have to understand, China is still the biggest market in the world.
Yeah.
Which the China, because they are still the world factory. Okay, if the world factory move out of China, China may go down a little bit, but they have enough population to use the end product. Okay, cellular phone is still very popular. If you look at the recent Huawei's cellular phone with threefold kind of things, you don't see anything in the world. They are very innovative to make a consumer useful kind of product, and this is China's strength. But the semiconductor is much upstream. It's a longer chain to when they get into a consumer, and that is the most difficult part for China. So China will survive with their market, and they will be isolated
a little bit,
slow down a little bit, but they will survive with their own market.
Do you think they will be able to have any breakthrough? Because we've seen all kinds of news, whether it's AI development or even EUV, there's some news about that technology breakthrough.
Let's just using some common sense to think about that. That SMIC as an independent board about 4 years ago almost.
So you were on the board of SMIC, right?
I was in the independent board from 2019 to 2021.
Okay.
Because of SMIC was put into entity list, I left right after that. Okay. Because of that 2 years, I learned quite a lot. Before that, I had no idea about China Semiconductor. I only have a legal suit with them. Okay. But anyway, so using common sense to think about that, again, I mentioned they have a market they can survive, and U.S. choke with export control. Anybody under the tribulation will normally think out the box, try to survive. It's called the human surviving skill. Even recently, DeepSeek for AI, they couldn't buy enough NVIDIA chips
Video
and
chips.
their data system, whatever data center stuff. They can build enough stuff. They have to find a cheaper way, easier way, bypass certain things to make things for their application. If you just think about from just application point of view, do you absolutely need all kind of computation, all kind of things to make it happen? I honestly speaking, I don't. I work at AI as an expert system without big data, without anything, and we still can make the life much better. It's only the super rich guys think that way. You're so resource for to do it. But when you are so short of resource, you'll find a way to fill your need.
Right. Do you think without U.S. export control, China would still have developed those more advanced technologies, whether it's chips or EUV, or because of export controls for survival, they concentrated their efforts on making sure they can survive?
Without the export control, they will continue to grow, go to 5 nanometers, 3 nanometers. They might be slower than TSMC. Okay, I think it's still very hard for them to catch up with TSMC because all the infrastructure. But because they have a market to do that, I think they will be number 2 in the world. With export control, it's very hard for them to be number 2. Okay, because they are limited to advanced technology. They will still eventually dominate the mainstream technology.
Well, I've heard that in a year or two, their foundational chips may actually replace Taiwan's market share.
In some cases, yes. Okay, if there's no geopolitics issue, if this is a free trading world, I think Taiwan needs the mature technology market will shrink because it will be taking over. But because of the geopolitical issue, a lot of people still hesitated or forced not to buy chips from China. The more national security chips still probably are under the geopolitics, but the consumer part will probably won by the economics incentives. So yeah.
Do you feel that Taiwan is anxious about its leadership position? I see a lot of Taiwanese media worried about Taiwan losing its edge, whether it's forced or not, to invest in America. Do you think that concern is legitimate?
You also was born and grew up in Taiwan, right?
Yes.
So you know Taiwan. Taiwan has been and is, maybe will be, a scales mentality country. I use 7 habits of 7 habits of highly effective people, Stephen Covey's quote. Effective person have a so-called abundant mentality. In Taiwan is a small island. They are short of resource, and they are being colonized by many countries from Netherlands, Spain, Japan. Sometimes even think China, the nation is also a colony in a sense. So they are short of everything. So they are worried about everything. They are scared about everything. Even for TSMC, it's already dominated powerhouse in semiconductor. They are still worried. They are still have this competitive mindset. They still want to.
That's actually healthy, right? For a company to stay on top, you kind of need to have that, always sort of living on the edge kind of anxiety.
Yes, absolutely. But there are some small no, because then you go to monopoly and you are facing some risk of antitrust. Yeah. So when you kill everybody in the world and you become the only supplier to the world, are you safe? Okay, the current situation.
This is kind of what TSMC is facing right now.
Yes, exactly. That's why in 2017, a few months before I retire, at that time I still have a one-on-one meeting with Mark Liu on a monthly basis. I already warned him to be careful, being so dominant, because none of our customers really wanted to have a single source. prior monopoly in history normally bring the antitrust issue. At that time, there's no U.S.-China conflict. There's no COVID. The world still pretty kind of globalization, but I still worry about antitrust back to 2017. So I suggest TSMC to help Intel a little bit if Intel becomes non-existent. And U.S. doesn't have a company working on advanced technology, TSMC itself will get into trouble. That's how I kind of.
Well, that is almost happening right now.
Yeah. That was 8 years ago. I have no clue. Whatever is going to happen.
So I know you've retired from TSMC. So
7 years ago.
But looking at TSMC's $100 billion investment in the US right now, and then given where Intel is today, what do you think happened behind the scenes? There are all kinds of rumors. There's some rumor about the US wanted TSMC to invest in Intel or even operate Intel's fabs. And even there's like sovereign wealth fund TSMC to do something to take over Intel. There are all kinds of rumors. What do you think really happened?
I really cannot represent TSMC, and I was as a PIP chairman for TSMC R&D, so-called Proprietary Information Protection Committee.
Mm-hmm. Can you say things that are utterly unreasonable, right? Just so there are not that many rumors. Because, I mean, disinformation doesn't help either.
Yeah, actually, those rumor are in some way reasonable. A lot of things is common sense, but depends on which point of view you are coming from. The rumor was not welcomed by Taiwanese people because the only thing they care is their safety, their money. Mm-hmm. They are not TSMC. So there are two sides of complaint to TSMC. They are all legitimate.
Yeah. And so, what are Taiwanese concerns?
I don't want to get myself into trouble. Mm-hmm. I don't represent TSMC. I'm just using a public report to explain the situation. The report is from BCG, Boston Consulting Group. They have two reports, one in 2021, 2024. I actually using that to teach my semiconductor class because it's open public report. I will never use any TSMC information.
Sure.
To do it differently. U.S. In 2019, market of advanced logic is roughly 34% of the market, but their capacity of making that chip is zero. That is where the real problem is. That's the bigger point to get TSMC into it. At least has the U.S. supply to fulfill that 34%. May not be 100% coming from the domestic, but at least have something more than zero. And that's the first phase of TSMC with $65 billion investment. The second report, they have a forecast of 2022 and then 2032. Okay, 2022, there was U.S. still zero because the TSMC fab still is a building. It's a build, not finished. They haven't output any meaningful revenue yet. Okay, 22 is still zero. They have a look at that forecast for 32. They predict U.S. capacity will reach to 28%.
Oh wow!
That report give you some idea what U.S. goal, at least to 2032 medium term, is trying to drive. Because the 28% capacity, 65 billion is not enough. That's why you need an additional 100 billion. And maybe yesterday or day before I heard someone say Trump seems to mention about 200 billion total. Okay.
He did say at the press conference that they'll keep coming, they'll keep investing more and more. So do you think there's any other better option for TSMC right now other than investing in America?
Very different. This is probably the best option for TSMC.
In the worst situation, right?
Yeah, the other option is making Samsung stronger, but TSMC probably don't like it. Or making Intel stronger to take that 28%, and TSMC may not want to say,
They tried. I think they tried.
Yeah, but Intel has a very huge hard time. I think very simple question is, if I'm Intel, what am I going to do to change my destiny? Okay, Intel recruit me a job. So since I'm going back to US, so I took the job. That's one reason. The second reason is I taught a class called innovation management. I want to prove I have a way to change that innovative dilemma to Intel. But after 1 week, I gave up my
only
idea.
1 week.
And because there's a lot of human issues, mostly human issue, mostly cultural issue, has nothing to do with technology. I consider technology is the easiest one to reach, but changing people is
culture,
very difficult.
Yes.
Very difficult.
So essentially, it is a business management issue for Intel.
It is more business. And Intel people always remember Andy Grove's golden era.
So what do you think is going to happen for the next 5 years?
Now let's go back to that. That report has the 34% advanced technology, and then US 0. Now we're going to reach to 28. In that report, has another 9% of the market called critical infrastructure. That including all the defense, all the telecom infrastructure build up, all the essential parts which are related to US government. TSMC go to Arizona can fulfill that 34% of a commercial application market, but I don't know how they fulfill that 9% critical infrastructure.
Yeah.
And that's why it got to be doing something to make that 9% still available, and that's what U.S. government probably care even more.
Another rumor is that they want to turn TSMC into an American company. And depends on how you define it. In Taiwan, it's like Taijidian, will become Meijidian. What do you think?
Okay. Now we focus on the report, the public report, 9%. There are a few options to make it happen. First, help a U.S. company, the real U.S. company, the current U.S. company, to fulfill that 9%. The best candidate, of course, is called Intel today. And that's part of the reason Intel
has to survive.
That's one option. The other option is divide TSMC into two companies. One is U.S. company, the other Taiwanese company that also can do that. And that's the area definitely TSMC doesn't want to do. And I go back to 2017 when I talked about to help Intel. Didn't know anything about whatever happening. I just had a gut feeling. U.S. need to have one company surviving in advanced technology, whatever option. And helping Intel is probably the best solution out of the worst situation. But we couldn't find anybody in U.S. today. I can only say what I know, what I see. I couldn't predict anything not happening yet.
Of course. Do you think Trump will still impose tariffs on semiconductors?
That one I definitely cannot predict. I always believe tariff is just a tool. Only when he has a goal to reach. He's definitely using that as a weapon, as a tool to force certain things happening. So I think he will continue to use this tariff to do whatever he wants to do. But today's TSMC investment can fulfill that 28. If it can fulfill that 28, it doesn't really have a strong need for that, unless during this time TSMC really don't make it happen. It's very hard to predict. Predicting Trump is impossible.
Sure, that's a whole business just to kind of predict what he's going to do or say. It's a very lucrative business. I'm sure you're already in high demand, and you'll continue to be in high demand because there's so much that is happening. I just heard a sigh from you. Are you optimistic, pessimistic?
Okay. I'm a fundamental optimistic person. Under the most pessimistic environment, I still am optimistic.
You also don't think Taiwanese should be that worried, right? Because there's certain level drama in Taiwan.
There's a phrase called disguised blessing. For example, Taiwan should establish a much stronger relationship with the rest of the world, outside of the U.S., outside of China. Semiconductor is Taiwan's strength. No doubt about it. It may be the only strength. We should leverage that strength to work with the rest of the world. We have so many opportunities. All over the world has so many opportunities. Instead of worry about U.S., worry about China, help yourself to be a stronger person facing the tribulation and survive with that tribulation. I actually call it being adult. I consider Taiwan is like a 妈宝岛. It's a paradise, but everything, all the issue is a government problem. When I go out facing some issue, because the government doesn't do things for me. I never want to complain. I never blame government. Government has its limitation. It's a bureaucratic organization. What do you expect the government will do? Definitely, government play a very important role of diplomatic and also defense. That's the part most people probably very hard to do.
You have made a lot of contribution to, at least in Taiwan, in the sense that your reasonable voice matters a lot. With the media being so sensational, at least your reasonable voice people do listen to. Oh, thank you so much for doing that. And of course,
thank you for this opportunity.
The story of Taiwan and semiconductors is about making the best out of a dire situation, about immigrants pursuing better education and economic opportunities, and about being pragmatic, hardworking, and seizing the moment. This is Perspectives with Wenchi Yu, where we analyze the policies and political strategies of Trump 2.0 and their implications for Asia, China, Taiwan, and beyond. Thank you for watching and listening to our 7th episode, the second in a 3-part series on semiconductors and geopolitics. We value your feedback. Please subscribe to our YouTube channel and podcast. See you next week.